So how are we feeling about SQL?
So far, so good. Pretty good. I think I already gave my homework in on Monday, but I've been working through the lessons. I mean, I've been getting through them. I just didn't do the projects themselves. I
Okay,
did the first project. I just didn't finish the other projects.
okay. So we are actually going to dive into a React concept that Jennifer actually brought up and we worked on in a one-on-one, and I think it's going to benefit you guys for all of your capstones. It's basically using this concept called an outlet, which allows you to kind of define a page template that's going to have all the different components on it, and then also allow you to have your different routes. So this is popular for if you're doing a nav bar. This is popular if you have a sidebar and maybe a footer that you want to put on every page, but you may want to have your login page not have your nav bar on it or something like that. So I'm going to send you this code. This is not something that you need to follow along with. I'm going to just do this in a little sandbox, and then I will share this code with you. But this is just an example, so you don't need to follow along with this one. So I'm going to pop open my terminal. I'm going to CD to my desktop and my...
Sharing your
Oh,
screen.
see, I'm out of practice. Okay, I'm changing to my C4 my code. I'm going to go into my week 17, which I don't have yet. I'm going to get into my week 17. I'm going to make one for week 3 or day 3 and CD into that. And then I can npx create React app. And I'm just going to call this outlet, and we'll see how that works in a second. Okay, we CD into our outlet project, and we npm install React router DOM. And I'm going to use the command open space period. That pops open the folder that we're in the terminal. And that allows us to pop this open. No, it just doesn't want to drag. Pop. You kidding me? Pop that open in VS Code. Okay, so we are pretty familiar with deleting this stuff out. And I'm just going to make 3 files. I'm going to make one called nav.js. I'm going to make another one called footer.js, and then I'm going to have my home screen. And let's do one final one called login. And this is a good overview as well. If you have not gotten your React project set up, I think most of you have, but at least this video has audio on it that you can follow along with if you need to. So I've got my footer, I've got my home. I've got my login. And I've got my nav. Okay, so we know that, hey, we want 2 different routes. So we're going to go to our app.js and we're going to get our browser router, our routes, and our route. And that path is going to go to the empty slash. And the element that shows up is going to be my home. Routes. I missed my closing curly. There we go. And I import my home from my /home, and I go to integrated terminal, I do my npm start. And that should bring me to the fact that route is not defined. Okay, so I've got my home and I'm like, all right, everything's good there. Now, what I could do is I could go to the home component and I could add in my nav bar here, right? I could put all of this in a div and I could say, hey, I want my nav bar to show up here. Of course, the autocomplete is not going to work for me, so I'm going to have to import it manually. And I could also put my footer on each page as well by just inputting it from here. And this is better than vanilla HTML because I don't need to copy and paste every single line of code from my footer. I can just copy in footer. Did I forget to change footer?
You had nav, you imported it from nav.
Oh, thank you. So I could do this and I could copy and paste this code on every single page. But what if I don't want to? What if I want to say, hey, this should go on every page? We can actually create something and we can really name this file anything. I am going to call this structure. I'm going to call it template.js. And just like any other component, we are going to define it and we're going to return a div. And then we are going to export all our default template. Now what we can do is actually modify our router. We can say, hey, there's going to be a route and it's going to use the path of an empty slash. It should show up on every page, but the element it's going to show up is our template component. And now when we have routes that we want to show up inside the template component, we're going to put them in here. So I'm going to put my route path login, and that's going to go to my element login. Now, we can agree that these two routes are inside this parent route, right? Because they're before this closing tag. So if I go back over to my browser, after I fix a quick import, nothing shows up. Well, these routes are inside my template. And if we go look at my template doesn't have anything inside of it. So it's almost like we need to give app.js the template and say, hey, there is an outlet for the routes inside of your template to come out of. And so that's exactly what we do. We come in here and we say, hey, we are going to import. And give me 1 second. I got to actually look at the React DOM router outlet. I think we just import outlet and then use it. Element nested in dashboard outlet. That's exactly what we do. So we import our outlet from React Router DOM and we put our outlet in here. Now when I come back over, I can see my home page. And if I go over to my login screen, I can see my login. Okay, well, what's special about this is that now I can take all of that work instead of having to import it on every single page. I can just use it in my template. So I can throw my nav in and I can say, hey, I want my nav to be on every page. I want my footer to be on every page. And then whatever route fires inside this template should show up in that outlet. So we're taking whatever path matches in the URL here, taking this component and dropping it in to the outlet in here. What that allows us to do is not only see that my login page has the nav in the footer and my home page now has the nav in the footer, but if for whatever reason you had a different nav bar or didn't want to show the footer on a certain page or whatever it is, you could take that route and move it outside of the template. And now that it's outside, it won't have the nav and the footer on it. Pausing there, does that make sense to you guys?
I know what we did when we were looking at my code. It makes sense, but can we like write it down?
Sure, yeah.
Yeah.
Exona, question?
I was just gonna say it doesn't make sense to me. Like I don't know. I lost you somewhere and I don't know where I lost you at, but
Okay.
I lost you.
So let me do a quick visual and then we can number everything out. So what we're basically saying is, hey, we know the import nav and footer. That makes sense, right? We just pull those in. Those will show up wherever we put nav and footer in here.
Mhm.
What the template allows us to do is to nest our routes in. It allows us to say, hey, home and login are going to show up as part of our template file. So what we're basically doing is we're saying when the path is home, go up into this template file, which is over here, make our nav and footer show up, then take whatever this element is and shove it into the outlet over here.
Okay, so the outlet is pretty much the path that. Okay.
It's allowing the whatever is inside the route to show up.
Okay.
And if for whatever reason we're like, oh, we don't want the login screen to show up with the nav and the footer, we say, okay, no problem. We're going to take this login route and move it outside of the template route. And because of that, now the login, because it's not inside of the template, will not show up with the nav and the footer.
Okay.
And the reason why we do this is because you may be tempted to come up here and say, well, why don't I just put my nav up here? That's still React. That's still in my JSX. The problem with putting it up here is that it doesn't have access to all the router functions. So if we put it up there, the link tag is actually not going to work. It's like I can't link to something that is outside of the browser, outside of the router. And so what we do is we use this outlet to say, hey, this template file, you can call template whatever you want. You could call it structure. You could call it navigation. You could call it whatever you wanted, right? The basic idea there is that you can make your template once and say, hey, I'm going to get my nav bar showing pretty, my footer showing pretty, my sidebar, my whatever's supposed to be on every page, but still have all the power of routing in here.
Okay. That makes sense. Just a quick question. Can you make more than one template?
Mm-hmm.
Okay.
Yeah, if you wanted to say, hey, I want, it's a great question. If I want template with no footer for whatever reason, we can take this whole thing, put it in here, and say, hey, I'm going to delete the footer out. And I want my login page to not have a footer. So I'm going to make another route out here. And the element is going to be my template with no footer, which I don't think I named properly in here or here. And then inside that route, I'm going to move my login screen.
Okay.
So now we've got our home showing our nav and footer, but if we go to our login screen, it might get feisty with me, but it is theoretically possible. Try and name this login and make that empty. See if that does it. Oh. Duh. There we go. Now our login has the nav, but if we go back to the home page, we should. Now the order is going to get picky on me. Okay, I know it is possible. I don't know why it's not working at this particular moment, but it is very possible to do
I don't
two
think you
templates
have-
if you needed to.
Yeah, I don't think you have anything on. Do you have anything in home? On home JS, did you write anything?
Yeah, I've got my H1
Oh, yeah.
here,
Oh,
and the template still has the outlet. It might be. Let me try it like this. If I take this one out, does it bring my home back? It does, so it's just a problem with this one. Turn my H1. Template no footer has my nav and my outlet. Template no footer. Huh, I don't know. That should theoretically be working. I'm not quite sure what I missed. Oh, that did it. Okay, there we go. Sorry, it took me a minute.
No, it's okay.
These paths kind of compound on each other, which makes it a little trickier, right? So if you wanted /login/ something else, you could actually combine these paths together. So you could say /test. And I believe in order to get to it, you would go to /login/test. And it's going to make a little liar out of me. There we go. So it's these beginning slashes that are actually problematic. So
Gotcha.
what you can do there is if you had like a group of things that are all related to login, like a create account and forgot password and all of that stuff, you could basically group them all together here, and that would make the URL /login/test in order to get that component to show up.
Okay.
Hey, Max, I don't know if this is relevant, but I remember needing to put the more specific endpoints above, like the home one. I don't know if that's worth noting.
It is for sure. Yeah, you want your kind of most generic, your easiest path to go down at the bottom. So that way, if it matches on anything up here first, it will show that one. Otherwise, it will get down to the bottom and say, hey, this will kind of match in. And because of that, we'll still show the home screen. So putting the home one at the bottom is definitely a good idea.
Question: how do you house, if you wanted to house everything in container, would you do that from app.js or like your home page?
This would be good to do in the template, because if you wanted your nav and footer to be part of it, you could just put your class name template right here, class name container, and that would house everything inside of it.
Okay. All right, I'll have to implement this template thing. Okay, thank you.
Just a quick question. So, if you go back to SRC,
Mhm.
And you see how you have the nav.js. What if it was a folder and then the nav was in the folder? How would you make it come out as a, like, for instance, if you were to create a folder that says lib and you have all the nav and the footer in there, how would you add
All
that
you
in?
need to do is it
It's
will
gonna-
ask me if I want to update my imports. Usually I would want to hit yes on this, but just for the sake of showing you, I'm going to hit no. And now I have errors down in my terminal because it's like you moved nav and I can't find it anywhere.
Mhm.
All you need to do is go to wherever you have it imported and update the path to include lib.
Okay,
And I also do that in template no footer, so I also have to put lib in that file path, and now it should work exactly the same.
okay, okay, cool. So you don't do anything with the sorry, if you can go back.
Mhm.
And the template where it says class name container underneath, it says a nav, you don't change that. That's how it's supposed to show.
The way the computer fires it off is it finds the file path here, which gives us access to it in this nav variable, which then makes it
Oh,
come down here so we can use it. So it
gotcha.
kind of
So
trickles down.
gotcha. So you use the variable to put it into the return portion. Okay,
Correct. And
gotcha.
just to really hammer home that point, we can actually call this anything. We could call this I don't know, America. And now it's going to break because it's like, hey, America is defined, but more importantly, we don't know what nav is. So
Mhm.
we could call this America here if we wanted to. And because this one matches with this one, and because this one is coming from the nav file, it will
Oh, it's
actually
control.
work exactly the same.
Gotcha. All right, cool. Thank you.
Generally, 98% of the time, we want to make all of the names consistent. So the file name, the component name, the export, and the import are all the same. But believe it or not, there are times where I will have two different nav bars coming from two different packages, and I'll need to rename one of them like navbar bootstrap or navbar 2 or something like that. So that's
Good.
why it's set up like that, so you can import different things.
Gotcha. Perfect. Thank you. I might have to do that actually, because I have a nav bar that's different on my homepage than it is for the rest of my website. So
Yeah, try and be consistent. Try and say if I have two different nav bars, I'm going to make the component name and the file name match. So one's nav bar login and one's nav bar, signed out or something like that. It is very common to have different user types. So to say, hey, the admin is going to have more links or more access in their nav bar. So sometimes you get like a nav bar admin, nav bar user. But that's kind of what this router lets you set up to say, hey, I'm going to cluster all the admin links together. And so the URL will end up being /admin/ edit college /admin/ new college /admin/ user management, right? And then all of those routes are going to be clustered together so that the right nav bar and all of that stuff shows up.
gotcha. Perfect. Thank you.
Any other questions on this?
No, this is very helpful. This is very, very helpful.
I am going to take out our second no footer just so we don't get confused with multiple templates. But then I will share this code in the live stream in case you need to reference it.
Hey, Max, I hate to be a pain, but do you mind sharing one of each, that in case somebody wants the double template, they have it? Instead of me.
I'm just worried about people getting confused on implementing it.
Okay.
Just because it's not common to have multiple templates.
Okay.
At least not in a capstone level app, but you can always go back through the video, or schedule a one-on-one if you need help getting this set up.
Does this have a name to it or is it just routing still?
It's still routing. The name of the concept is called outlet. And the outlet is part of nesting routes would be the other like category or term that this feature falls under.
Is that similar to like the whole React drilling thing? Nesting routes?
You said React drilling?
Route drilling, I meant, but yeah.
Route drilling? That's probably, let me look that up.
It's the whole nesting routes thing, which gets
Yes.
confusing for me.
Yes. I've heard of prop drilling before. I've never heard of route drilling. But it's kind of in that same realm of nesting routes. So yes, it's probably the same thing. Let me just make sure that this is working. And believe it or not, this is a newer feature in React. It has been around in other routers for a while, but React Router version 5 or 6 is what implemented the ability to nest routes in other routes. And then, of course, if we're doing that, we need to put in this outlet so that when we put this home route inside of our template route, it knows, hey, home, and is supposed to come out of this outlet, right? If you think about, we're giving this template file in, the template file knows to show up, but we are telling the template file, hey, you have to have this placeholder, this hole for whatever route matches to go into this outlet. So let me share this quickly on the live stream. And I'm going to say my template comes over. And my login. And then finally, my footer. And I think I also did not share my nav. I even have a nav? Where did my nav go? Oh, it's in the lib. That's why. I'm going crazy. I know I had that file somewhere. All right, we are going to dive back into Khan Academy. Let me get there from tonight's outline. Tomorrow we will be going into database design and figuring out, hey, all of these videos are cool and they make sense, but how do we know how to structure our data? How do we take everything that we did in Khan Academy and actually apply it into our projects? So we'll be installing Postgres. We're going to be installing a program called Beekeeper. We're going to learn how to execute our queries, and then we will be diving into database design, theories, entity relationship diagrams, all of that stuff tomorrow. Jennifer, go ahead.
Hey, could you put the template tab up again, please? I'm just making some notes off of it. Thank you, thank you.
Max, I will say, I only got through to a couple lessons on Khan Academy, so I'm not far.
We're going to start where we left off, which is querying the table. And then as we go through them, you'll have a couple minutes to complete the challenges as we get to them. But I am going to try and do it on a little bit of a faster pace just because I was out yesterday. And we're going to try and get through as many as we can. And then whatever we don't get through, hopefully you guys can practice on your own.
Cool.
And the first one isn't a great example, but I do try and do my own examples. I do try and explain it after the video explains it, just in case hearing it a second time a different way makes it click. So if you were going through it and you're like, I don't get why we do this, tonight is all about asking questions, because if you don't, you just kind of learn it in a vacuum and you don't understand what you're telling the computer to do. So definitely ask lots of questions tonight if anything pops up. Do we have any final questions on the outlet stuff?
Can I please look at the app.js tab again? Thank you.
Now, keep in mind, my login is outside of my template. So I'm saying I don't want the nav bar to show up or the footer to show up. But because my home is inside of the route, that will make the information on the template, the nav and the footer and the container show up. But then it's going to take whatever element it matches on inside the template route and make it show up in my outlet. And Exona, before you ask, not only can you do a template, you do two templates. You can actually do a template inside of a template, depending on how far you want to nest down.
Okay, thank you.
I don't know that you will want to do that.
I will
but
probably not.
It is
It's gonna
possible.
make things way more complicated for me, but thank you.
The worst part about this is when you implement it and you're working on your site and you're like, I have two nav bars and I have no idea where the second nav bar is coming from. And so you're going through all of your code and you're like, why do I have two nav bars? What have I done to anger the programming gods? And it's because like one's in a template and one's imported at some level that you forgot about.
Yeah, I can already foresee it happening to me.
Okay, so anything that is in the template root path, anything nested in the template root path will show up
in the outlet of the template component if the path matches whatever's in the browser. Right? Because if we had home and login in here, home and login wouldn't show up, only whatever was in the path that matched. So the template would always show up, but then what showed up inside the outlet would either be the login or the home screen.
How do you know that outlet over here in the template connects to app?
Because the template is defined as the outer parent route and element and component, and then the login and home are inside the template route. And we only get to pick one route per level, which is intentional, right? We only want, that's the whole point of a router, is saying you're either going to go to the login screen or to the home screen, but either way, those are going to show up in the outlet that has the nav and the footer because they're inside this parent template.
All right, the template has the nav bar with a footer.
Max, at that point, is it accurate to just think of the outlet as baked into the template once you get into your app?
Yes.
file? Okay.
Yes. And so if we take a look at how this actually shows up, it says nav home footer, but if we open it in the browser and go into the inspect tab, we can actually see that working. Where's this div class container? That's coming from right here. That's coming from our template. Okay, now what's in our nav file? What's in our nav file is the H1 of the nav. So what do we see? We see the H1 of the nav. Okay, now where's this div coming from? That div, we have our outlet. So we've got to go back to app and say, okay, which one of these two pages are we on? We aren't on /login in the browser, so that means we must be on the home. So we go into the home and we see the div in the H1, which means everything inside this div is going to show up inside where this outlet is. And we know that it's coming from there because if we switch back over to our app.js, we can see home is coming in from our import, which is coming in from the home file. And then, of course, we finally have our footer, and our footer is coming in because that's also part of the template.
All right, so the app has the browser router, the route path
Mhm.
template.
Mhm.
The template houses the login and the home,
Routes,
right? Route
which
path.
means because they're inside the template route, they are going to show up in the outlet of the template.
They are in the template element, so they will show up in the outlet.
And because it's a router, it will only show one route per level. So it's going to either show login or the home page based off of whatever path we're on in the browser.
Okay, so that's how the home page ends up on the nav page.
On the template page, in the outlet of the template page. We're either going to take the login component and dump it into the outlet, or we're going to take the home component and dump it into the outlet.
Mm-hmm.
And depending on what path we're on in the browser is going to control what shows up in the outlet. If we're in the browser, we get the home page because look at our URL. But if we go to /login, we get login. We don't get the home page anymore, but we still have the nav in the footer because we're taking whatever element, whatever route fired off from this. And because this is inside of the template route, it's going to take login because the path is /login and make it show up in the outlet.
Any route path in the template route path. Okay, I'm gonna mute you for a second so I can remember this.
Any other questions? We feel like we can take this concept and apply it to our capstones.
And
Not
the
saying, go ahead.
Sorry, the number of routes that can be within the template doesn't matter.
Doesn't matter.
Cool. That's all.
So not everyone's capstone will have this. If you're building a single page application and you only have one page, you don't even need a router. Or if you have 4 or 5 different pages, it may not be a pain for you to add a nav bar to every single page. But oftentimes when you're working within a web app, you'll think about the header and the sidebar and maybe the footer that's on every single page. That's how they can achieve something like that without having to either import it on every single component or having to copy and paste it, which is what we would have to do in vanilla HTML. Think about your nav bar. Every time you want to change a single link in your nav bar in vanilla HTML, you would have to go to every single page and update that URL. Well, with React, we could import it on every single page, so we only have to update it in one place. but we still would have to put our navbar import on 40 different pages.
Mhm.
And so that's what this template allows us to do. Sometimes they call it a template, sometimes they call it a structure, sometimes they call it layout.js. Layout might actually be a better name for it. Doesn't really matter what you call it. The general idea here is you understand, hey, because these routes are inside of the template, they're going to show up inside this outlet. And then whatever else is in that template will always show on the screen if whatever path is matching in here matches on that element template. With all of that said, can we run back to the safety of SQL?
Yes, safety of SQL.
Thanks.
All right. We're going to pick it up where we left off with querying the table, which is probably, arguably, the most important database operation. Need to stop my screen share just because I don't know if it is sharing the sound. It's not. Okay, off we go.
We're back with our groceries table, but we've expanded on it a bit. It now has a column for which aisle number we can find the item at the supermarket, plus we've added a few more items. Now you can really see the power of SQL in different ways that you can retrieve data from your database. And this is also where it can get a bit tricky. To start off simple, how would we retrieve all the rows from our table? To perform any query, we write select, and then which columns we're interested in, like the name, and then from, and the table name that we're selecting from. And we can see a list of the groceries on the right under that results section. But what if we want all of the column names? We can just replace name with star. And that was also the query that got inserted when you click the table name, which you might remember from the first talk through. This list is out of order though. If we went from top to bottom at the store with this list, we'd have to keep changing aisles. We'd rather have it ordered by aisle so that we can be more efficient at the store. To do that, we can just add an order by clause to our query, specifying which column we want to order by. Ah, that's better. Now we can get our ingredients faster. But to be even more efficient, my brother and I like to shop together and split the store so that I shop in half the store, he shops in the other half, and we meet at the checkout. There are 12 aisles at this grocery store, so for my list, I just want to know which items are in aisles 6 through 12. Well, anytime we want to filter results out, we can use a where clause for this and specify the column name and then what we want to compare it to. So in this case, I used a greater than operator, but there's lots of different comparison operators depending on what it is we're trying to filter by. Great. So now I know exactly what items I'm going to get. I'm going to be really efficient. And you've learned a few ways to use SQL to query. Now stay tuned to find out even more ways that you can select.
So we're going to go into the challenge, but if you're looking at these videos and you're like, all right, they keep on throwing more keywords at me, how am I supposed to know what all of these keywords are? There will be certain ones that you will memorize, select, insert, create table. Those will be kind of baked into your memory with a little practice. However, just like with JavaScript, if you go to W3 Schools and do a search for SQL, you will find every keyword that we use over here on the left. So if you're in here and you're like, that order by, how did we do that order by? Here is all of the syntax and a little demo database where you can scroll down, see the example, try it yourself, and actually hit run SQL and have it sort everything out. So for whatever reason we wanted to sort by city, you could practice in here by changing that to city and seeing, hey, now it's all sorted by the city's information. So W3 Schools is, as always, a great resource. I actually really like it in SQL because they let you try it out. I have seen several hundred, if not thousands of lines of SQL queries where they got really in depth in terms of what they were trying to get out of the database and cross-referencing a lot of different tables, which is something that we're going to learn later tonight. So just wanted to throw that out there as a resource. That is also in the outlines for tonight and yesterday, are a little reference to this. Jennifer, go ahead.
I also noticed that when I'm in the challenge, at the bottom of the page, there's about or documentation. And then I can look at the documentation and find a lot of that as well.
Yes. And that's a great resource as well. I think I am cheating and sharing you the answer. So I'm going to give you guys just a minute to work on that challenge box office hits database.
Do you want to see it if I already did it?
No, you're fine. If you already did it, you're good.
Okay.
I am going to start a poll though, just so I can see where you guys are at. Okay, so first step is saying, hey, this database is already made for us. We've already inserted all of this data, but we are going to kind of filter through the results of the database. So it says in the first step, just select all the movies. Well, we can select, and then we could put our column names in here. We could say we want the ID and the name and the release year, but we don't need all of that, right? What we can just say is select star. That star is a wild card, right? It's saying select all the columns
You're not
from
sharing your
Excuse me,
screen.
Max, are you, okay.
our movies. So from here, we got our first step done. We have selected all the movies. Now we break down step by step. It's saying now we want a second query after the first. So we don't modify this query. We put a whole nother one in there. So we say select star from movies. Again, the select is saying, hey, go select rows from the database. The star is saying any column in the database. The from is a keyword, so it knows the table name is going to follow it. Then we put in the table name. Now it's saying that only retrieves the movies that were released in the year 2000 or later, not before. So we say where, which is another SQL keyword, where, and then we have to use the column name, where the release year is greater than or equal to 2000. Okay, well now here's our first query. That's our select showing up right here. Here's our second query with the information showing up, but we have to go look at the last step here. Sort the results so that the earlier movies are listed first. So what we do is we add in our order by, and we could order by name if we wanted to, but we don't want to order by name. We want to order by release year. Good. Cool.
I have a question. I'm sorry.
Shoot.
I might have missed this, but the order by, is that always ascending or is there a way to reverse it if you needed to?
You can, if you do DESC,
Oh,
it will
okay.
be descending, and then if you do it ASC, it will be ascending.
Thank you.
We're back with our grocery list. I can see that it has 6 rows in it, but I can also see that we need to buy more than one of each item, like our bananas. So I'm not sure offhand how many items we'll end up buying total. And I'd like to know that total number so that when we're cashing out, we could just do a quick check to see if we have the right number of items in our cart. Well, to do that in SQL, we can use what's called an aggregate function. An aggregate function is useful for things like getting the maximum, minimum, sum, and average of values in our database. In this example, to get the total number of items, we'll start with select, then the name of the aggregate function we'll be using, sum, then the name of the column we want, and then from the name of the table we're selecting from. Ta-da! So we can see on the right that the sum is 15, so we should have 15 items in our cart if we got everything correctly. And notice if I go up here and change the number of bananas, because I'm going to invite my monkey friends over for a jungle party, we can see the sum increase in real time and get bigger and bigger, so we know that we're now going to need 67 items in our cart. Now we could easily try out other aggregate functions here, because sum's not the only one. So if we wanted to know what is the most that we'll be buying of any one item, then we could use max. See, 56. Those are obviously our bananas. But this information is useful for this case. Let's go back to sum. Okay. Now, what if we wanted to make sure we had the right number of items after each aisle? Well, we can do that in SQL using the group by clause. We add it to the end of a query, specifying the column name to group by aisle. Okay, so now we can see that in one aisle we have 9, another of 1, but I don't actually know which aisle we're getting each of them in. So what we can do there is just add aisle to the beginning of this select. So there you can see, okay, so we're going to get 9 items in aisle 2, 1 item in aisle 4, 56 in aisle 7, and 1 in aisle 12. Awesome. Now, how did that actually work behind the scenes? The SQL engine first did the grouping of the rows based on aisle. So first did this group by, then it summed up the quantity in each of those groups, and then finally it selected the first aisle value that it saw in each group. And the aisle value was the same for all of them, so we got the aisles back out. But we could have also said name here, and we do see a name for each of the rows, but it's a bit misleading because for some of these aisles, there are actually multiple items in that group, but the SQL engine just picked the first item out of it. So you really shouldn't be using something different from what you're grouping by, because you might not get a sensible result. So we'll say aisle, and now that's an accurate presentation of our data. Okay, so great. You've seen aggregate functions, you've seen group by, and now you can efficiently gather useful statistics on your data. Another tool for your SQL toolbox.
So we learned that basically here we don't just need to specify the column name. There are functions that are built in, not only after the from and the select and all of that stuff, but we can modify our columns by taking averages or finding the max or the min in the column, right? That can be really helpful when we have data sets of thousands of items. To go back to the insurance example, we were curious, what's the most expensive insurance claim that the company has ever paid, right? And we were able to do that with a max query to say, all right, go find whatever the maximum number is in this column. And, we got something, a claim that was like for hundreds of thousands of dollars for a hospital stay that included some gene therapy and stuff like that. So when we analyze large data sets, it's helpful. But it's also helpful to kind of look at the data here and say, okay, why are we getting a sum of 9? Because there are multiple things in the aisle, right? Groceries, the peanut butter is in aisle 2, the dark chocolate bars are in aisle 2, and the cherries are in aisle 2. So if we add up those quantity numbers, we're able to see, hey, there are a total of 9 items, even though that is not apparent in this data. Because we're able to modify our selects, it makes it a little bit easier to understand the data that's in there. Show of hands. How many people have completed all the challenges in lesson 1? Okay. I'm going to give you guys a minute then to work on this. And then I will go over the answers with you. Oh, you little liars. 4 people already have it done. I only saw 2 hands raised. Still give everyone a minute to catch up, and then we can get on it.
I have a quick question, Max.
Yep.
So on the challenge on unit on lesson 2,
Mhm.
it gives you different I guess tables that you could choose from.
Mhm.
Are you supposed to copy all of that and put it into your project?
What challenge?
So the challenge for the, hold on. It sent me directly to it, so I gotta get the data dig. You gotta,
Yeah.
that sends you to GitHub, and the GitHub information all is in there.
Yep.
You have to copy all of that and put it into your project.
You would. Yes.
That's why I didn't do it. I wasn't sure if I was supposed to.
Jennifer, go ahead.
Thanks. I have select minutes from to-do list. And what you've got there. And it's telling me if I have multiple select statements, I have to move the sum statement. So it's the first one, and that it's easier for them to grade.
Do you have a underscore between to do and list?
Mm-hmm.
Do you have a semicolon at the end?
Yes.
Okay, go ahead, share your screen.
Am I on the right one?
Yeah, so they're just saying, you should read the end of it. It says you should only have one select statement. Right here. And we have two of them right here.
Oh, and I
So
don't
if-
have to have both of them. Okay.
So if you cross this one out, you should be good to
Yeah.
go.
Okay. Thank you.
I think their editor supports command / as well, which will put in a 2 double dashes. That is the equivalent of a comment in SQL. But you should be good there. Do we have any questions on the challenge before we move forward? Okay.
At this point, you've probably heard me pronounce SQL two ways, SQL or SQL. Some of you might even be mad that I'm pronouncing it one way or the other, and you may have very good reason for believing that your favorite pronunciation is the correct one. So what's the deal? Well, SQL was originally invented at IBM in the early 1970s, and the first version was called SEQUEL, and it stood for Structured English Query Language. That acronym, SQL, was later changed to SQL because SQL was already trademarked by an airplane company, and companies really don't like getting into trademark lawsuits. Nowadays, many of us still pronounce it SQL because it's shorter to say, and we've got historical reasons to claim that it's the right way. However, when I surveyed developers across the world, I found that in non-English languages, many of them pronounce it SQL, or, for example, SAQLA in Spanish. Since our videos get translated here on Khan Academy, I figured I'd make it easier for translators to match the pace of our videos by pronouncing SQL the long way. But in everyday life, I'm used to calling it SQL, so both of them come out of me. Now you know, it can be SQL or SQL, and you'll probably hear both the rest of your life. The world is a messy place, but at least you now have a way of structuring your queries about it, right?
So for the sake of time, we're going to skip over the projects and only focus on the challenges tonight. However, if you're looking to get a little bit more practice, you are welcome to do them. Also keep in mind that the homework for this week is called SQL Bolt. That's on another platform. So if you want to get a jump start on your homework and get some practice in, you're welcome to continue over there. All of these concepts should translate because that's the whole point of SQL, is that is a structured query language so that it doesn't matter what database that you're practicing with, that SQL travels across any database, any relational database that you use. Okay, moving on to lesson 2.
I've spent the last few talkthroughs making a grocery list. Well, now that I've realized how much eating I do, I realize what else I should be tracking in a database. How much exercise I'm doing. So, I'll start by pasting in some statements that create a table and insert a few rows of data. Let's see what I have in exercise logs. We have an ID, of course, a type, which is a string like biking or dancing, minutes for how many I spent, calories for how many I burned, and heart rate for how high it went. Now, I'm inserting the data using a slightly different syntax than before. Notice how I'm specifying the column names in parentheses after the table name. When I do that, it means that I don't have to specify every column value here. I only have to specify the ones that I give in this list of column names. Now, do you see which one I didn't specify here? The missing column is ID, and that's very much on purpose. ID, here we go. The ID column is the primary key in the table, and it's set to auto increment. That means that the database will automatically fill it in for us when we tell it to, by picking an ID that's different from the other rows in the table, usually a number that's one bigger than the biggest number so far. Now, I would rather have the database figure that out than have me figure it out. So I usually like to do my inserts this way, leave out the ID, let the database do that work for me. Okay, so there we go. My database table is set up, and it looks like I've even done a bit of exercise. Go me! Let's find out where I'm burning the most calories with a simple query. I'll just modify this one. So select from exercise logs where calories greater than 50, and we'll just order by calories as well. Okay, so I've done 2 activities where I've burned more than 50 calories, and it looks like dancing burned the most. Now, I want to find out which activities I've done that have burned more than 50 calories, but also taken less than 30 minutes, because I want to exercise more efficiently in the future. It's pretty obvious from looking at the current results. There's only 2 results. It's easy to look at that. But just imagine that there are thousands of rows. Maybe this is data from thousands of users. I would need a way to filter that down in the SQL query itself. To do that, I can use the AND operator to combine those multiple conditions, like to only return the rows where calories are greater than 50 and minutes are less than 30. Haha. So now I only see one result, dancing, which means I should just spend my whole life dancing, which sounds pretty good to me. Okay, so in a similar way, I could use the OR operator to return rows that meet any of some conditions. Like, let's say rows where calories are greater than 50 or heart rate is above 100. And that helps me find the most vigorous exercises. Now we can see that dancing and biking are both good, and actually I do like biking. It's just a bit harder. Now you can have as many OR and AND operators in your query as you'd like. The AND operator has precedence over the OR if you've got both of them in the same query, but you can always use parentheses to change the order of evaluation, just like with math expressions. Now I want you to try these out in the next challenge, and stay tuned for the next talk through where I'm going to show how to do some interesting things using this type column here. See you then.
All right. Take a minute, work on the challenge, and then we will move on to a review in the next video.
I see that you have the duration as 4 times 60, but I'm guessing that's. I just put 240 and I got the same thing, but okay, cool. I didn't know. Good to know. Thanks.
Max, excuse
You're
me.
muted.
I'm muted, sorry.
You're muted.
Yeah, exactly. You could put 240 in there. That would work perfectly fine. Just an example to show you that you can do some math. And if you needed to, like she said, you can use your parentheses as well, but they're all different kinds of data types. So some databases may store information in hours, some databases may store it in minutes, right? So it's very common to see math inside your SQL query because we're just lazy as developers. And it, just quicker to enter that in that way.
Gotcha. Thank you.
Jennifer first and then Artra.
Thank you. Am I supposed to capitalize title?
Title can be lowercase because titles are title columns in the database are usually lowercase.
Okay, it doesn't like me.
Go ahead, share your screen and take a look.
It's so simple. I have select star title from songs, semicolon.
They want you to select only the title.
Star selects everything, right?
Correct. So delete the star and put in just title.
Oh, okay.
Artrell, go ahead.
Thanks, Max. The second part of this project had me stuck for like a couple of hours at work today. And then I realized, like a dummy, I forgot to use the word duration. That was the only thing that was holding me back. I'm like, what is wrong? Like, what am I missing? I had the seconds right, everything. And it's like duration. And I'm like, oh my goodness. If I would have just read it again or looked at all of my values in the table. It's just crazy, like how just the littlest thing could just throw everything off.
Yep. Absolutely. Yeah, you get better at picking those things up. But that's why rubber duck debugging is a good tool to actually, if you're really stuck on that and you're staring at it and you've got no one you can ask for help, sometimes it helps to pull out a piece of paper and write down every word and then move it onto separate lines, right? And then say, okay, in English we know, and if every sentence needs a verb and a noun and all of that kind of stuff, can I do that with my SQL? Can I say, hey, am I explaining, if I'm putting a where in, am I using the column name? Okay, if I'm using 2 column names, do I have my and in there, right? Getting down to that level of saying, hey, do I have my table name in? Do I have my column names in? Do I have my select words in? And that can help you get to realizing what's missing.
And that makes sense. But even with all of that said, I probably wouldn't have caught the duration. I just totally somehow just missed that.
Sometimes you can, in the instructions, go in with a highlighter and say, okay, this is one thing that I know I'm going to need in my query, and then switch to another color and highlight another one. Sometimes colors are a good trick to help you on that as well.
Okay. Thanks, Max.
Any other questions?
I'm back with my table of exercise logs, and I've added a few more rows. Now, if I wanted to filter these logs to just show my biking logs, I could just add where type equals biking. Simple. It's getting sunny outside, so actually what I want to find is all of the outdoor activities, not just biking. So to do that, I can use the OR operator that we just learned, checking each of the different outdoor types. So type equals hiking, or type equals tree climbing, or type equals rowing. Unfortunately, I don't yet have a mountain or a tree or a lake in my home, so all of these are outdoor activities. All right, so that worked, but there is actually a simpler way to do this query, and that's using the in operator. The in operator will check to see if a particular value is in a list of values. Let me show you. So we'll take this query and I'll paste it. And then I'm going to replace this equal sign with in, and then put a parentheses. And then I'm just going to separate each of these strings with a comma instead of that whole long or type equals blah.
So you can think of
Ta-da!
in as an array.
Same results like we expected, but this query is easier to read and it's a bit shorter too. We could easily also do the inverse query if we just want to see the indoor activities. We just write not in. Ha. So that's just dancing, and I'll save that for the winter time. Let's change it back to in and our outdoor activities. And I'm going to show you something a little more interesting that we can do with in. First, I'm going to need another table of doctor recommended activities. I'll paste in the SQL for that. Let's see, where do we have it? Here. So here we've created a table of doctor recommended activities, which just has a type, which matches our type from up here, and a reason, which is why the doctor recommended it. Now, what if I wanted to see all my exercise logs that correspond to doctor recommended activities? Well, first, I might want to see what are those doctor recommended activities. So select type from doctor's favorites. Okay, biking and hiking. So I could just take this query and modify it and just shorten it to biking and hiking. However, if the doctor's favorite tables changed, like there was a new row added or a row deleted, then this query would be out of date. What I want is for this query to always be up to date with what's in this table here. So what I can do is use the in operator directly with the results of a SQL query, a select query. And it's actually very simple to do. I'll replace what's in the parentheses with the query that we did before. Ta-ta! Cool. So we call this inner query a subquery. It's the query that we're doing inside the outer query. And now this query will always pull based on whatever's in the doctor's table at the time. It will stay up to date. And this is a pretty simple subquery, but it could actually get really complex. It could be as complex as any of the queries that we've learned so far. Let me show you an example. What if we only want to select the favorites that the doctor recommended for cardiovascular reasons? So we could say where reason equals, and then we could paste this whole long reason in here and we see hiking. But what if for some reason we didn't have the period in here? Well, now we actually see nothing for that query because it's trying to do an exact match and it can't exactly match that. So there are times like this when we want to do an inexact match, and we can do that with the like operator, which is a pretty neat operator. And so to do it, we're just gonna take this and I'm gonna replace the equal sign with like and get rid of, because all we care about is that very important word cardiovascular. That is what we're looking for. So we say cardiovascular and we also put a percentage sign on either side, which acts as a wildcard. So this should match any rows which contains the word cardiovascular anywhere, and it did. Yay! Okay, so that's pretty cool. Whew. We covered a lot in subqueries like. Hopefully you're pumped to try them out in the next challenge, or take a break, go climb a tree and come back. Either way, I hope you have fun with it.
So we start getting into several tables worth of data, right? This like operator, she's not kidding, is very powerful, right? If we want to look through an entire database worth of data and match things that might not be exactly formatted the way we want. For example, we may want to, look at some text input the user entered, but you don't know if they put a space at the end of it, if they entered it in uppercase or lowercase, you don't know. Maybe we're just going for a keyword in the sentence. Using where with like is very common to be able to say, hey, I'm looking for something that has this somewhere in the name of it. The student who did the grocery store app, right? When they typed in chocolate milk, they didn't want they were looking for Wegmans chocolate milk or, you know, Burn Dairy chocolate milk, 2%, right? All they cared about was, hey, we're looking for something inside of that product name that matches. And so it's very common to reference both tables. And in a minute, we are going to get into, hey, we're doing 2 queries here. Can we write one query that spans both tables? That is called a join. However, we are going to take our break, work on the playlist challenge maker. Over break, if you have any questions, let me know. Otherwise, I'll see you guys at 7:25.
Wait, so we're working on the challenge playlist maker on our break or when we come back?
Either. We'll see where
Okay.
people are at when we come back from break. And then we can move on to the next videos. So things are getting a little bit more serious now, right? We've got this table. We've got the name, the country, and the genre. We've got all of this musical information, and we've got a lot of values in the database. So the first thing it wants us to do is to select the title from all of the songs by the artist named Queen. So we say select, we say title because they say only select the title from our songs table where the artist is equal to Queen. Okay. Now we're able to modify that if we want to get out the next step, which is selecting all of the artists. Selecting all of the titles from the songs where the artist is in a subquery, right? So we're saying, okay, pause that first query. The database isn't actually going to run that select first. It's going to run this select next. That says, okay, get the name from the artist table where the genre is pop. Then take the results of that table and make sure that in our songs table, the artist is inside of our subquery. And from that, we're going to get out all of those titles. That makes sense?
Was that the last step or the second step?
That was the
Oh, the last step.
last step. I think the second step was this one right here.
So can you explain it again? Because that's the step I was having a hard time with.
Yeah. So we want to think about this as we've got 2 tables worth of information, right? And sometimes it's easier to visualize it if we just throw a select in here. So we're going to say select star from artists. And then we're going to say select star from songs. So the songs table only has 3 pieces of information: the ID that isn't going to help us, the artist, and the title. But if we go up and look at the artist table, the artist has their name, their country, and their genre. So now we're trying to line up this data. We're trying to say, hey, we want to know what pop songs are in our songs list, but we can't get access to the genre pop or whatever other genre we want to look at, because that's in the artist table. So the first thing we do is we say select a name from artist where the genre is pop.
Okay.
Now I only have my pop artists. And because that's in a subquery, we can say, hey, select all the titles from songs where the artist is in the result of the pop artists.
Okay. Got you.
So sometimes it's also helpful not only to do the select, but to move this out into its own query and say, okay, what am I getting here? I'm getting Taylor Swift, Celine Dion, Rihanna, because I'm querying that table, right? And I'm only asking for their name where the genre is pop. So I'm using the different columns, I'm filtering it down. Now I can take those results and say, hey, go select all the titles from the songs table where the artist is listed in my subquery here.
Okay. Makes sense. Thank you.
No problem. Not a substitute teacher here, just, he didn't play on the YouTube video. All right, moving on to our next groups.
Max, I'm sorry, I could use a minute because I'm still stuck on the karaoke song selector. Are you able to help me with that?
You're muted, Max.
Here, screen. Thank you, Latonia.
Okay, thank you. So I've tried a few combinations.
So you only need one where. So you can take out that second where. And there you go.
Oh, cool. All right, thank you.
No problem. Okay.
Let's continue with more queries of my exercise logs. Let's say that I want to see how many calories I've burned for each type of activity. We can do that with an aggregate query. Say select type and then sum calories from exercise logs, and then we're going to group by type. Now I can see each type with how many calories I've burned total for that type of exercise. Now, do you notice how the column shows up as sum calories in the results? If we want, we can actually tell SQL to give that column a new name just by writing as and then giving it the new name total calories. That can make our results easier to read, and it also has another benefit, which we'll use later. So next, I want to filter the results to only show activities where I've burned more than 150 calories total across all the times I've done that exercise. It turns out that 150 calories is the amount in 1 ounce of dark chocolate, so it seems like a good amount to shoot for. Now, my first instinct might be using where to filter. Like if I took this query here and then said where calories greater than 150, then we only see dancing and we don't see biking, which we would expect to see. The reason we only see dancing is because it filters each individual row that comes in. And dancing is the only exercise where I burned more than 150 calories in a single log. But what I want to know is which exercise type or types have I burned more than 150 calories across all of the logs for that exercise type. We actually have to use something new for that, which is the having clause. To use that, we'll remove this where, and then after the group by, we'll write having, and then total calories greater than 150. Ta-da! Now we see biking, because now it's actually looking at the total calories, and I've indeed earned more than 150 over time in my logs. So as you can see, those two queries are actually different, but they are easy to confuse. When we use having, we're applying the conditions to the grouped values, not the individual values in the individual rows. We could use any aggregate function on a grouped column that makes sense. Sum, min, max, average, whatever we want to check. Let's do another example. So if we want to see the average calories for all the exercises where we burn, let's say more than 50 average total. Oh, that's all of them. So let's up it. 100 in the middle, still doing good. 70, cool. So you can see we can play around with that query there, get different results with that having. Now let me do something a little different. let's say we want to see all the exercise where we logged at least 2 activities for that type of exercise. For that, we're going to use a count function. So I'll select type from exercise logs, group by type, and then having count star, doesn't matter what column, so we can just do star, greater than or equal to 2. Okay, so now we can see biking, dancing, tree climbing. I've done all of those at least 2 times. Makes sense because those are my 3 favorite activities in life. Besides coding, of course. Okay, so now you've seen having. Remember that it's easy to confuse having with where when using these aggregate functions. So think through your results and make sure they make sense. And now you get to try it yourself.
As much as I love this next challenge, I want to make sure that we get through everything as quickly as possible. So I am actually going to skip over the queries that I haven't written in a couple years, and focus in on the important parts here. Not that if you are interested in SQL, if you're like, I want to do this full time, you should definitely go through every one of these, right? Being very powerful in SQL is great, but we need to get more into the updating queries and stuff like that. So I'm going to just speed through here. One of these is who issues SQL queries, right? How do we write these? Why are we learning SQL? All of that good stuff. And they break it down into kind of 3 different sections. One, the software engineers, right? Us. We need to store data. We need to make sure the data is organized. We need to make sure that only the user can see their user data, that the user can see other people's user data, but only if they're friends, only if it's public. You can think of a dashboard. There's a lot of information in that dashboard, but they need to be able to display it and programmatically access only certain pieces of that data in the database. Data scientists will often learn SQL because their data set is so large, it becomes unmanageable unless they know how to properly query it, how to do different analyses, pull your averages, all of that stuff. And then finally, product management may take a look at this, right? You may be logging everything a user does on your website, and you may want to know how much time do they spend on this page? Where do they scroll to first? Based off of how much time they spend on this page, do they actually buy our product? How many support tickets come in about this page compared to the amount of time spent on it? Right? That is all part of SQL, of being able to analyze those huge data sets and really convert it into information. And while you may be thinking, all right, well, I can do all of this in Excel a lot faster, remember here that this is all about how can we get the user to be able to interface and save with our data, and how can we work with huge data sets? And that's where SQL really comes in as a strong player. Okay. I really do love the Wordiest Author Challenge because you get into your grouping and your having and understanding that your having is different from your where. Remember that you use your having when you have some sum or some group or some mathematical operation. That's what helps you get your having working. But I am going to speed through here onto relational queries because this is where the magic really happens. So so far we've been working with one table, right? And that's not entirely true. We did have a second table for artists that we were cross-referencing, right? We were saying, hey, go get the pop artist from this table and make sure that that list is cross-referenced with the songs, because we only want to see artist songs that are coming from that other table. So this is a perfectly valid table. We have our student name, our email, whatever tests they've taken in the grade. We may also keep track of the student's name and the book title and what books they've read. And we may have all of that detailed information about the student in some third table. The problem that we start to realize, though, is that there's a lot of duplicated data. What happens when one of these students gets married and they change their last name? Well, now we have to go through and update not only Alice's last name, but we need to go into these other two tables and make sure Alice's name is updated there. Does anyone else see a problem with the data specifically around the student's name? Down here, we've got the student's first name and the student's last name. But up here, that is combined. So what happens when we want to send that student an email and we want to say dear and whatever their first name is? Well, based off of this table, I wouldn't actually know what their first name is. Now you could say, yeah, Max, you would just, see where the space is, and whatever's before the space is their first name. Well, what happens if you have someone who has a double last name? How do you know if their double last name is their first part of their first name or part of their last name? So it's usually preferred to store the student or to store the information split out. And that's why oftentimes when you're placing an order online, you'll see first name and last name as two separate fields so that they can maintain that over time and know, hey, you may have two names in your first name or two names in your last name, and they can tell them apart so they don't accidentally mix that data. So basically what we end up doing here is starting to make the data more relational. Instead of storing the student's name, we're going to store the student's ID. And based off of their students table, we are able to then take the ID from the student and the ID of whatever table that is referencing and smush those together to get the result that we're going for. Now, I know that's theoretical right now, so let's see how the join works, and then we can go into that a little bit more.
I've set up two tables in this database. A students table with detailed information about each student, like their name and email, and a student grades table, which has their student ID, test name, and grade. Let's see what happens if we just select everything from student grades. Ta-da! Okay, so we see student IDs, test names, and grades. I'd actually rather be able to see student names, emails, that sort of thing. Now, what you might notice is that the student ID in student grades is related to the ID in students. So this 1 here is actually referring to Peter Rabbit, and this 2 here is actually referring to Alice in Wonderland. Now, I want to form a query that will output the student name and email next to each test grade. And that information is in 2 different tables. So that means I need to join the tables. And there are a few ways that we can do that in SQL, and we'll try them all out actually. The simplest is called a cross join. And I can make that happen just by putting both table names after the from. Ta-ta! So as you can see, lots of rows. And basically what this did is that for each row in the first table, it created a row for each of these rows here. That means we end up with 8 rows because it creates 4 rows for each of these 2 rows. This is the simplest join, but it's also the least useful. We don't want every row matched with every other row. We only want them matched if the student ID matches. Now we can do that using an inner join, which isn't actually much more work at all and is way more useful. So there's actually a few ways of doing an inner join. We'll start with just building off the last query, and we can add a where. And the where will check to see that the student ID matches student's ID. All right, so now we actually have what we wanted, is test grades next to names, because it's done the cross join and then just limited to the rows where those columns were the same. Great. This syntax here is called an implicit inner join, and it works, but it's not actually the best practice. The better way is if we do something called an explicit inner join. And that is using the join keyword. So to do that, we're going to start with just doing from one table. And actually, I'll do from students and then join on student grades. And then instead of where, we do on. And that specifies what columns are being matched. So on students.id equals students grade dot student ID. All right, so now we have the same results as before. Switched, but really the same. Now that I have these tables joined, I'm just going to whittle down the columns I'm outputting to the names, the email, the test name, and the grade. Okay, beautiful. Now, the cool thing is, once we've done joins, we can still use where and group by and all those fancy things. Like, let's say that we want to filter down the results to just grades greater than 90. Woohoo! Let's see. Oh, no. Grade. There we go. Haha. Lots of ones above 90. Now I can email all those students with a high five. Okay, but what would happen if my tables both contain columns with the same column name but different meanings? Like right now, our student grades table has a grade column. Well, what if my students table also had a grade column for their overall class grade? That would mean down here, when we selected grade, it wouldn't know which table to pull it from because there'd be a grade column in both of our tables. So actually, to be super safe, we should prefix our columns with the table name that they're from. So we say students.firstname, students.lastname, students.email, studentgrades.test, studentgrades.grade. Okay, now we know that we're going to get the columns from the table we expect them to be in. Great. Now that is our basic explicit inner join, and it is what you'll use for most of your joins across related tables. But if you stay tuned, I'll show you a few other types of joins as well.
She will, I won't. Inner joins are very, very popular, right? Inner joins are how we make sure, hey, when a customer changes their address, how do we update it in one row, in one table, and make sure that it applies to any of the previous orders or when they make any new orders, right? That order is going to have a ton of information. I have placed probably over 1,000 orders at Amazon, right? But I can update my address in one place and know that it's going to be updated everywhere on the Amazon site. That is the magic of an inner join. It doesn't really matter if you use implicit or explicit. Explicit is supposed to be a little bit more efficient, but at the end of the day, they accomplish the same things. And this to me just makes a little bit more sense, right? We're selecting from two different tables and we want to overlap those two tables together. So what an implicit join is doing is if you think about the Venn diagram, it's taking the student grades and the students table and then using the student ID to smush those two together. And where the student's ID in the student table lines up with the student ID in the grades table, those two align and we are able to get a table that's showing us this information. And if we need to filter it down a little bit more, we can. They do go on a little bit later to show you how you can do a join on its own table. You can do joins with multiple tables. You can do all different kinds of stuff here. But I think it's worth it just for a minute to go through and look at this challenge. And then we will be moving on to Unit 4, which is way more important because it has all the CRUD in it. Create, read, update, and delete, right? Which we've already seen insert and we've already seen select. So we've got our read and our create already going, but we don't have our update or our delete yet. So I'm going to do this one moving into lesson 4, and then lesson 5 is just like hey, where do we go next? So we've created a database of people and hobbies, and each hobbies is related to the persons via the person ID column. In the first step, insert one or more rows in persons, then one or more rows in hobbies that is related to the newly inserted person. In other words, we're going to make a person, and then we're going to go use that person's ID to insert a hobby that they like. So let me clear this. So we come down here and we've got all of these hobbies and we've got all of these people. So I'm going to say insert into persons. The name and age columns are the two that we want. And we're going to add in me. I'm an old soul, 99. Okay, so we're in here. Now I've got a problem. If I come down here, they want me to add in the person ID. Oh, I forgot a comma. And I'm looking and I'm like, person ID, I just inserted myself here. I don't know what my person's ID is. So what I'm going to do is I'm going to select star from persons where the age is equal to 99. Now I come up here and I say, oh, my ID is 6. So 6 must be the ID I need to use when I am inserting a hobby for myself. So I'm going to come down here and I'm going to do my insert into hobbies. And my person ID and name are the two columns I'm inserting into. And the values for those two columns are going to be 6 because my person ID is 6 from the persons table. And I'm going to insert the name of the hobby, not the name of me, the name of the hobby, because that's what's going, the table that it's going into. And I'm going to add in programming. Okay, now we've added that information in. But that is split across two separate tables. So what we're able to do here is using the explicit join, we can say select all of the columns from both the persons table and the hobbies table. But now look at what's coming in here. It's putting my name against all these different hobbies. If I even get to the top, the age, the person ID, the name. And I'm looking here and I'm like, no, I don't, meowing isn't a hobby of mine. I don't know whose it is, but it's not, I'm not a big meower. What I need to do is come back over to my select and say where the person's dot ID equals the hobbies dot person ID. Now I've got my table filtering down, but there's still a lot of information in here. So I'm going to take it a step further and say, you know what? I only care about the person's name and the name of the hobbies. Now I've got my data in two separate tables. I've got my person's name over in the persons table. I've got my hobby name over in the hobbies table. But because both tables have a person ID, I'm able to come up with this table where it can show me my name and any skills that I may, any hobbies that I may be interested in. And remember, that's coming because my ID here was reused when we inserted the hobby right here. So if for whatever reason I wanted to make Bobby McBobbyface into programming as well, I could come up and try and find Bobby in my persons table, and he happens to have the ID of 1. I can take that ID of 1 and insert it right into here, and now all of a sudden, where did I type a 1? I didn't mean to type that. Oh, my computer hates me. Persons. And if I change this one to 1, now we can see Bobby is into programming because that person ID coordinates. Person's name next to their hobby. I'm pretty sure we accomplished that. Any questions on a join? They would like us to write it probably the more efficient way, which would be, hey, select from this table, an inner join on hobbies, and then on persons.name is equal to hobbies. Oh no, persons.id is equal to our hobbies dot person ID. I still don't have it right.
I think the way that I had it was only join instead of inner join,
That might be it.
and on persons.id equals hobbies.person ID.
I'm still missing
They're
something.
probably reading the one before that one, so they're not gonna give you the.
Oh. Nope, they just. Person's name next to their hobby, name, hobbies.
And when I added the person, I didn't insert two, I just did the regular. Was it the insert two?
Insert into persons. Oh, you know what? Maybe it's the select from persons. I had an extra select in there. Which makes me think the other way would have worked as well, but whatever. Any questions on that? We had the right answer there. It just had another select in there, and it was like, no, you're not selecting the right thing. So when we took that other select out, it was fine. This is the most important thing to learn of joins. If you are interested in getting into databases, if you're working with large data sets, I would encourage you to keep on working on the different kinds of joins. But I can say, as a professional programmer full stack who's been doing this for 10 years, I've never used anything other than an inner join. Okay, on to, believe it or not, the last lesson. There is a lesson 5, but it's just next steps.
Let's say that we want to create tables to store the data for a diary app. A basic setup would be a users table and a diary logs table. Now, when a user wrote up their diary on the website, we would have some code to execute an insert statement like what I'm pasting in here. So this inserts 2 rows for 2 diary logs, one day after the other. First, where somebody has a horrible fight and buries their woes in 3 pounds of dark chocolate, and the next day, of course, they make up and celebrate with ice cream, as you do. So we can check to see what our diary logs table looks like now, and we can see those 2 posts in there. Now imagine that the user comes back and wants to modify their logs, maybe because they don't want to admit even to themselves that they have eaten that much dark chocolate. Now we've already inserted the data, so at this point we would need to have code that would execute an update statement like this: update diary logs set content equals I had a horrible fight with Ono's guy. Now this is telling it to update that table and set the content, but it's not telling which row to update. We need to tell the database which row to update because we don't want it updating every row with that content, just one row. So how do we find the log to update? Well, we can use the ID like that. If we didn't know the ID, we could also filter by columns that we knew were unique to the log, like user ID and the date. It was 2015 0401. But really, if you know the ID, it's safer because you're not relying on having to filter on columns, which could actually be the same across multiple rows. If you might have a diary app where users are allowed to write multiple logs per day. It really depends on how the app and the tables are designed. I'll go back to the ID since I know the ID. Now we can do another select to see that our table changed. And it did. No more knowledge of those 3 pounds of chocolate. Okay, so the user made that change, but then the user decides that they actually want to delete the entire log entry. Like maybe because they want to forget that they even had that horrible fight. So in that case, we would need to have code to execute a delete. So we can say delete from diary logs where, and once again, I'm going to use the ID because I know it. And let's select again to see what it looks like. Haha, so we only have 1 row left, which means that our delete worked. Now, you should be very careful whenever you're doing update or delete, because you want to make sure you're updating the actual rows that you intend to update. You don't want to update the wrong rows or delete the wrong rows and lose that data. In fact, some apps never issues deletes. They never really delete rows. Instead, they add a deleted column to their database, and then they'll do something like deleted equals set deleted to true when the user wants to delete, and then they filter based on deleted equals false in the select queries, something like that. So that means that you never actually delete data, which can be a little bit safer, but it's a little more complicated to do that as well. So anyway, that's up to how you design the app. So now with select and insert and update and delete, you have all of the commands you need to handle what a user would want out of your diary app. And now hopefully you can better imagine which commands are happening behind the scenes when you use your favorite apps every day.
I cannot stress enough how important that where is, because believe it or not, this is completely valid SQL to just do the first part of this update. So if you're in here and you say update diary log, set content to that, and forget the where, it goes, sure, no problem. Finds every single row in your database and sets the content equal to that, whatever you just updated there. And when you go, oh no, I didn't mean to do that, I wanted to just update this 1 row, you better hope you've got database backups, because there is no edit undo in SQL. Yes, we're in some playground right now, right? And we're able to delete that line out and see things on the right and everything's fine. And I believe this playground is even set up to make sure you can't accidentally set every single row to that one piece of content that you're trying to update. But when we get into SQL in the real databases, there is no edit undo. There is no reverse statement, right? When you run that query is run. Wasn't a big deal when we were doing our selects, not a big deal when we were doing our joins, because we're not actually updating or deleting anything in the database. We're just reading from it, right? That becomes much more important now that we're learning these update queries and these delete queries. Always make sure you've got your where, because there is no Command Z in SQL.
So when is it actually updating the information? As soon as you finish typing it, or is there something specific that you need to do to be able to put it through?
Yeah, so this is a bad example because it's running the second that you get that semicolon in there, it's running that query. However, in Beekeeper Studio, which is the program we'll be installing tomorrow, we'll actually set up our first database, be issuing our SQL commands, but it won't run when you type in the semicolon. It will run when you literally move over and hit the run button. So it's kind of like when we were using Node and we were like building things in the terminal, we could write all the code that we wanted, but nothing happened until we went back into the terminal and ran the Node command. The same goes for SQL. There are no real SQL programs that will auto run queries for you, because that is insanely dangerous. Instead, what you'll do is you'll highlight the command or the query that you want to run and then actually hit the run button, and that's when it will execute.
Insanely dangerous. Why?
Because you could be writing something like this update command and forget that you didn't put this where on it. So if I'm writing this command out and it saw that I was done and I put a semicolon in, it would go and update every single row and set the content of every single row to this new string. So really, I could have copied and pasted that in and then gone over to my notes, gone over somewhere else and turned back, and that query would have run. And I'm like, whoa, I didn't tell that to run. So that's why while we're learning and in this environment, it's fine, right? It's not a big deal. But there are some databases that will prevent that from running now. They will say, no, you have to have some where clause. But default in SQL is that it will run the query, whatever you tell it to run. And if you forget that where off of there, you could update every single row in the database when you meant to really only focus in on one ID or one row. I don't know if it will let me do that, but let's see what happens. If I come in here, I'm going to comment all of this out. And I'm going to say, hey, I want to run an update on my documents. And I'm going to set the author equal to me. Now I come down here and I have my select from documents. I forgot a quote. And now look what the table is doing. Now I am the author of every single book in my database. And I'm like, no, I don't mean to do that. What I meant to do is set author where the ID was equal to 1. And now it's only updated mine. So just because we're in Khan Academy, we can get away with saying, no, undo that. I just meant to do this one little one. But in the real world, that wouldn't work, right? So we want to be really careful whenever we're doing that update or, for example, this delete, where we always put a where clause and then we specify whether it's the ID or the title or something that's unique. We really want to make sure that we're only updating that correct part of it.
Thanks for that example. That helped a lot.
Artrell.
So if you did make that mistake that you just spoke about, could you write another line of code to kind of ignore the rest of that? Even though you can't delete?
Because once that query runs, that query has run. There is no command Z of the query. There is no, oh no, put that data back. So when you are working with production grade apps, every database will have a backup. And if it doesn't, you've got a really bad DevOps engineer or deployed it very poorly yourself. Once you lose data in the database for the first time, you learn your lesson and you set up backups. And so we have had times at work where I have run what is called a migration in the database, basically saying, hey, our table structure has been updated, or we need to store some new piece of information, or and I've written that query and I didn't forget the where, but maybe I didn't set up my where right. And so I get a Slack message 5 minutes later after that migration has run, that those SQL queries have run, and they go, Max, where's everything that I worked on yesterday? I go, what do you mean? They go, well, everything I worked on yesterday is no longer showing up in your app. Where did it go? And so I go back and, I'm pulling my hair out, I'm sweating bullets, and I'm looking and I go, oh, I ran that migration wrong. And so at work, we have one main database, and that backs up every night at 3 a.m. And not only does it back up every night at 3 a.m., there are actually protections built into the cloud to make sure that no one can edit, modify, or delete that backup for 14 days. And the reason why we have that is because when you have a disgruntled employee and you let them go, fortunately, this has never happened to us, but if I have a senior developer on my team, we are a small team, they have access to everything I have access to, because if I'm out on vacation, they may need to be able to get in there and modify any of that. So we actually have a lockout at our hosting level to say, you can't delete this backup for 14 days. You can download it, you can restore the database, you can do all of that stuff, but for 14 days, you cannot delete this, you cannot edit this. And so that is our safety net for if a disgruntled employee deletes our entire database and then leaves, we have those locked in backups that we can restore from. So we won't get into too much of database backups, but that is certainly a thing that you learn in DevOps, and a lesson that you learn, unfortunately, the hard way once of, hey, I need some backup of this. The other thing that helps with that is once you deploy your apps, which you'll be doing the third to last week when Nathan comes back, you're going to deploy and your database is going to be up on some server somewhere. And so when you're working on your laptop and you run that delete command and forget to put a where in there and all that data disappears, it's only disappeared from your laptop. You can always go to your production server, get a copy of it, and import that back into your local database. And that's what we call a dev environment, right? We've been having a dev environment so far with npm run start for React, or hitting the live server and seeing that show up in the browser, right? That's what we call our dev environment. But once we push that up to GitHub, that's our production environment. That's where people on the internet can actually go see your website and interact with it and all of that stuff. So that is another safety measure as well. And so we actually have as developers, we have production accounts, but the entire top bar of the app turns red. And it goes, whoa, 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 you are in production here. If you delete something in here, it's gone, baby. This is what our users are seeing. This is the real life database. And so there are times that there's a legitimate reason for us to go into production and make a change. However, at bigger companies, oftentimes you won't even get access to the production database because you have it working locally on your computer, and any changes that you make to any code in production need to be reviewed and go through DevOps before it's actually running on the internet. Very long rant to a very good question.
It makes sense. Thank you, Max.
Yeah. Any questions on this?
I'm just stuck on the restoring part. So you can't, like undo, but you can push an old database and replace it.
Yes. Yes. And believe it or not, oftentimes those database exports are thousands of lines of SQL that just have a bunch of insert intos. And that's what it's running, is thousands of SQL. It will delete the database. It's called dropping the database. It will create the new database. And remember, the database is kind of like the holder of all of the tables. And then it will start creating all of the tables again. And once all the tables are created but empty, it will start running those insert commands in order to get all of the rows to come back into the table. Wonder if I can get an example SQL file. So here's an example SQL file. And all it's doing is it's creating our table, and we've seen this syntax before. Then it's doing an insert where it's specifying all of the columns, and then it's going through and inserting all of this data into the database. Now, this is only 3 queries or 2 queries, one's for the create, one's for the insert into, but there are SQL files that are hundreds of thousands of lines long because all they're doing is loading that data into the database. Okay. I actually do not have anything else. Oh, we should do this one. Last one.
We're back with the database for our diary app. Now, when we first created these tables, like the diary logs table, we decided to store user ID, date, and content. And
Now I want you to imagine that a few months after we launch this diary app, a user designer suggests adding a "how are you feeling" drop down on each diary entry. And the user would say something like happy or sad or confused. In order to store that, we need to add an emotion column to the table. Now, we could just add it like this, but if this was a database for an app in a real production environment, then we couldn't just edit the create statement because that's something that we actually issued months ago and it's already happened. And if we rerun it, it'll actually remove the current data. And we don't want to lose all the data that we've gotten over these many months. So at this point, after we've done create and after we've got data, we're going to need to use the alter table statement. And to use that, we write alter table and then the name of the table, and then add, then the name of the column name we're adding, and then the data type of that new column. Great. So now the next time that the user makes an entry, we'll need to specify that column, or we can specify that column. So let's say, all right, let's say they went to Disneyland. And to specify that new column, we're going to put comma emotion. And then here we'll just say happy. Most people are happy that go there. Okay, so let's see what it looks like now if we select it all. So we can see the latest row has happy in the emotion column, and the row before it has that big old null in it. And that is what databases usually do. They fill in null for unspecified values. If we want, we can actually get it to fill in some other value for rows where it wasn't set. And that's what we think of as the default value for a column. So to do that, if we had wanted to do that, we would have put default and then the value in that alter table statement when we ran it. So now you can see instead of null, we see unknown. So that's an option for you when you're adding a column, and just something to keep in mind, depends what you're adding to the database. Okay, so now let me show you something that you rarely do, deleting an entire table. Maybe I would do this if I migrated all the data out of this table into some new table, or if I just got mad and decided to be a horrible person and take a rampage all over a database. That's bad. But anyway, we can do this using the drop table statement. And now if I try to select, what happens? I actually get an error because my table no longer exists, so it can't select from it. So that was a bad idea, and I'll just delete it. You should think really carefully about dropping tables. Do not just drop them willy-nilly. You should also be careful with alter table, especially if you're running it on a table with a lot of rows, because you can have performance issues there. Really, I don't want to scare you, but you should be careful whenever you're making any changes to your database. With great power comes great responsibility. And now you have both.
Okay, and now that's all I have for you guys. So if you would like to use the last 10 minutes to complete some of the challenges, or if you're stuck on the homework, I can stick around for 10 minutes. Otherwise, you guys can head out and have an awesome evening. Or if one person asks me a question, I can find a way to give a 10-minute answer like I usually do.
Hey Max, just asking for a friend, but
Yeah.
During tomorrow's meeting with you and I, how bad are you gonna stab me if I got like close to no work done? What if I got like, let's just hypothetically say none done.
So hypothetically, if I needed to like pause the recording tonight to make sure I wasn't on the record, no, it's fine. We'll get you started. The thing that we did at the beginning of class tonight where we got the router set up is going to be the first steps anyway, because you're going to want to get React going. You're going to want to have your components in. You're going to want to have a nav bar done. So that's what we can focus on tomorrow. I will get this recording up tonight so that if you need to reference it, you can.
Okay, I just also
but-
might need to catch up on some things, so I want to ask you like how the best way to do that would be.
Sure, not a problem.
Okay, thank you very much.
I would like to go back through because I got behind. So I'm like, I don't know, half an hour behind probably. So I'm gonna go backwards and look at that.
Sure.
But I will have a few questions. while
Yep. I will stick around for the next 8 minutes.
Max, I have something of a rogue question about tables, but it should only take a few seconds. So we saw that we were manually numbering the items in there. Is that typical if you have like a smaller database, or do you, okay, you generally would have an auto ID system?
Unless there's something where, let's say the IDs are already generated. So
Mhm.
let's say that you're building an app to sign up for college courses, and all of those college courses have a course code, right? Writing 101 or whatever. That may be a time that you have a primary key that is already established, that, some other system created it or whatever it is, and that's when you would specify an ID. But outside of that, no, you almost always have the database generate an ID. And even when you think you don't need an ID, it's still a good idea to have one. There are very rare exceptions to that. I do know someone who had, I think, 48 million rows in his database, and SQL can only count so high. And so the table just errored out and said, we can't put in the 48 millionth and one row because we can't generate a number bigger than 48 million and save it. And so the right answer in his case was to say, oh, well, I'll never have a negative ID. So you can double the number of numbers that you can keep track of, because I will never have an ID of -1, -2, -3. Again, extreme edge case, but I do know someone who has actually run into that because they had 48 million rows and legitimate, think about how many comments get posted on Facebook in a day. 48 million is an easy number to get up to if you think about every single comment that gets posted. Obviously, we don't need to worry about that level of scale in our databases. But it is something that every now and then you will find the bounds of SQL. And oftentimes you find that by making a mistake when running a query, as opposed to, actually running into issues. But no, the database almost always will generate your IDs for you. Kalai.
Can you tell me what is limit and offset in SQL?
Yeah, so limit is going to say, hey, we've got 100 rows in our database, but we only want to see the first 10 of them. Offset is saying, hey, I want to see the next 10. How do I offset that? So how do I say, I want page 2, I want the next 20 different results? So here, let me show you.
That was in the homework, so I was just trying to figure out what is limit and homework.
Let me see. Okay, so we've got our query results here for our clothes, and we have 4 different items in it. So if I wanted to, I could say, hey, I only
Can
want
you share the screen, Max? Sorry.
more mad at myself. We could say, hey, there are 4 items in the clothes table, right? So we see 1, 2, 3, 4. Now, if I only want the first 2 of them, I can say, hey, limit my results to 2. Now, if I say, okay, well, I still only want 2, but I want 3 and 4, I want to go to the next kind of page of those results, you can use offset and say 2. So now you're getting the 3rd and 4th, because we're still limiting it to 2 results, but we're saying not the first 2, offset that to get to the next 2.
Yeah.
Limits you will use a lot. When I was working in the database with 27,000 rows or whatever it was, those queries would take a long time to run. And so I would do a limit statement to say, hey, just test this on the first 100 or the first 1,000 rows so I can see if it's working. And then once it is, I can remove that limit. There will be times where you'll have, 1,000 comments on a photo, and you'll say, well, I'm not going to put 1,000 comments on the screen. I'm going to put 100 comments on the screen, and then the user can hit the next button and get the next 100 comments. And that's what that offset is for, is to say, hey, I just want the first 100, but then if I want the next set of 100, I could offset it by 100 or 200 or 300, and that's how I'm going to get my pages of comments, so to speak.
Could you explain to me what running a query means? Is that just pulling information to show to the user?
Yeah, running a query that's what we were kind of talking about with when we type the semicolon in Khan Academy, it's automatically running the query for us. But when we go into Beekeeper tomorrow and we write out our query, it's not going to run until we actually hit the run button. And then whatever we've typed in is either going to be a query or it's going to be multiple queries, and it will go through and run all of them. So running a query basically just means take whatever SQL we typed in and tell the database, now go run it, now go execute it, now go make that happen.
Okay.
It's kind of like, I guess a good analogy would be saying we're writing all of our code in VS Code, but it doesn't actually happen until we go over to the browser and we look in the browser. So in our VS Code, we can write whatever we want, but it's not actually going to happen until we open it up in the browser. The same goes for running a query. We can write whatever query we want, but the database isn't going to actually run it and execute it until we hit the run button. And that will be a lot more obvious tomorrow. But if you still have a question after tomorrow, let me know.
So this homework assignment is due on Sunday,
Yes.
11:59. Okay. Perfect.
Not the end of the world if you don't get it in or you're a day or two late, but hopefully it gives you a little practice and pushes your resources. And I think it's a good one.
I'm gonna need, obviously, I'm gonna need a database for my project. I think I need
Oh, all of you will have a database for your projects. That is an optional.
Yay. So yeah. Great.
I will say, I don't mean to inspire panic by that. If you have a website and you've got your information loaded and you're like, I don't know if I can get all this information in my database, that's okay. We will find some very, very small feature, whether it's a contact form, where when someone fills it out and hits the submit button, it saves in your database, whether it's a little thing where you're like, all I want is my users' names to show up, and when they register, that shows up on some page. Like, we can find some lightweight way to integrate a database with one table into your capstone. And the reason why we push for that is that's what makes your capstone full stack. Is, okay, I've got my front end and I've got my React, but what's the stack? The stack is also the backend API and also the database server. And so that's what we're going for in your capstone project. I thought she was a little too still for my liking. So anyway, we'll be getting into that. Don't panic now. We haven't even touched APIs. That's next week. Next week, we start making our own API server, and then we go back to the chat app and we start layering in the database. And then we go back to the weather app and we start layering in the database there. And then we go to the blog and we layer it in there, right? So we've done this before. It's nothing to panic about. Lots to learn. Final call for any questions.
Yeah, can I look at one last?
Yeah, go for it.
I don't know what I'm missing.
And you guys are welcome to head out if you want, or stick around.
I don't know what I'm missing. I get that they want titles from songs, which is the name of the table.
Yep.
And let's see. And they want the mood.
So we don't specify the unit. We don't put seconds in at the end there, because to the database, that column is just a number. And take out your last select there. That's just dangling down at the bottom.
Yeah, I thought I had to write another one.
And there you go. Oh, you may have missed the step before this, or you had it and then you modified this query.
Well, maybe.
It was.
I'm not sure.
It was this one. Request. It was basically do this exact query, except you only care about the release date,
Mhm.
and it could either be epic or released in 1990. So you must have had that done in order to get to step 3, but then you started modifying the step 2 query.
Maybe. I don't know.
So just because there was 3 separate steps, they wanted 3 separate queries. That's all.
Okay. So I'm not too far off from understanding this then.
No,
Yes. Okay. Well, I'll keep-
it's one of those things that you're like, it should be more complicated, right? Like databases are a big deal. Shouldn't this be harder? And it's like, don't worry, it will be, because databases are just one piece of this,
Mhm.
right? So we're going to play around with our database tomorrow, and you're going to have it in Beekeeper, and you're going to be able to see these. You're going to install your first database server. You're going to run these queries, and you're going to be like, okay, all of this is great, and I feel like I have something powerful, but how do I use it? Right? How do I get it outside of Khan Academy? How do I get it outside of Beekeeper? All this data is sitting here and we can run all of these queries, but what does that mean? How do I use that database? That's when we take the next step and say, hey, we're going to make you full stack by building your first API that's going to access the database and make that information show up on the front end.
Could you store like links and stuff in databases? Like
Mm-hmm.
yeah, okay.
Mm-hmm. You typically don't store files in databases, but you can store all kinds of information, including links. Yes.
Okay. So I need to catch up with, let's see, Unit 3 relational queries, joining tables, and Bobby's hobbies. Is that right?
Yes. The lesson 3, you just need to do Bobby's hobbies, which is the relational. And then I would say you probably want to do all of lesson 4, which is only 2 challenges. And there's nothing in lesson 5 other than what to learn next.
Okay. All right. Be ready for me to bug the heck out of you on Saturday morning. Thank you. I'll see you tomorrow.
I'll see you guys.